Hello guys, this is Dr. T and welcome to Clinical Medicine with Dr. T. So this series that we have started on neonatal jaundice is going to be longish, and the reason why it's going to be longish is because it's going to be a bit long because we haven't really done the basics on the channel before. So as a build-up, let's do the basics. So please, before you watch this video, please make sure that you watch the part 1 of this, where I discussed production of red cells from the bone marrow and the different progenitor cells and how do we get to erythropoiesis, briefly, and the breakdown of red cells. But I'm gonna briefly mention it again. So here we've got a red cell. We've got a red blood cell. And we did mention yesterday that in there you've got hemoglobin. And hemoglobin, when red cells are being broken down for whatever reasons, maybe they are old and all kind of that, or maybe when there's a kind of a hemolytic condition, so the hemoglobin is going to be broken down into globin, which is a protein broken down into amino acids and is used in erythropoiesis again to produce red cells. And then here you get on the hem portion you get that enzyme that we mentioned yesterday, that it acts on the non-globin portion. And that enzyme, we did mention that the enzyme is heme oxygenase. That heme oxygenase enzyme breaks this down, and the product is going to be iron, is going to be carbon monoxide, and then is also going to be bilirubin. It's going to be bilirubin. Now we're interested in this molecule, so the iron is going to go and be recycled, and then it's going to be used again during erythropoiesis, right? But now bilirubin, now we have our bilirubin. There's an enzyme called bilirubin reductase. Bilirubin reductase that will come and act on this bilirubin molecule and produce unconjugated bilirubin. Unconjugated bilirubin needs to be transported to the liver for conjugation, to be conjugated, right? But we have a problem. Unconjugated bilirubin is lipophilic, meaning it's lipid soluble. It cannot be transported. It can't transport itself, so it needs a carrier protein. So that carrier protein is albumin. So albumin comes in and say, oh, you want to go to the liver. This is albumin. So albumin will come in and then bind to this unconjugated bilirubin. They will form a complex, and then that's how it gets transported to. So this complex comes in and is uptaken by the hepatocytes. Because why do we need to conjugate this unconjugated bilirubin? One reason is to be able to excrete it, because we want to excrete bilirubin. We want to keep bilirubin in controlled amounts in the blood. So we want to excrete it. That's why we need to conjugate it. Right? And another thing, for the babies, unconjugated bilirubin is toxic. It causes CNS manifestations. It damages the central nervous system, the brain, because of these two properties. So converting unconjugated bilirubin to make it to be conjugated is protective to a neonate's brain. Right? We are going to talk about what condition do neonates get when their brains have been damaged by unconjugated bilirubin. We are going to talk about that. But what I want you to get at this point is that we are converting it because we want to excrete it. That's the number one reason, right? But converting it from unconjugated bilirubin to conjugated is also protective to the babies. By the way, phototherapy, that's what it does. Phototherapy takes unconjugated bilirubin and conjugate it because of this same reason. But we're going to talk about that later. So remember, the bilipid layer has got a phospholipid layer, right? It's made up of, this is a cell, right? So cells are like that. They've got a bilipid layer, which is a lipid, and then with those tails. So whatever that needs to enter the cell from the outside needs to go through the bilipid layer, right? Needs to go through that bilipid layer. Any substance that is lipophilic, that is lipid soluble, enters this easily, radially, easily. But when you've got a substance that is lipophobic or water soluble, it doesn't enter there. It gets repelled. Because remember, the bilipid layer is charged. So substances that are lipophilic, they enter easily from the outside of the cell to the inside of the cell. Now remember, the blood-brain barrier has got a bilipid layer as well. So this is why unconjugated bilirubin is able to cross the brain, the blood-brain barrier, and enter the brain and cause damage into the brain of neonates. So jaundice in a child is not something that is what to call it. It should be taken serious. It should be taken serious. So now that we get this, I mean, remember, a drug that doesn't have an ability to cross the blood-brain barrier, that drug will never have brain effects. For a drug to act in the brain, it needs to cross the blood-brain barrier. And crossing the blood-brain barrier, it means you must go through the bilipid layer. Right? Okay. This is very important. I mean, if we are talking about neonatal hyperbilirubinemia, but you don't mention this, we have not done justice to the topic. Because this is the worst case scenario. This is the worst outcome, or this is the worst consequence of hyperbilirubinemia in these neonates. It's when unconjugated bilirubin crosses the blood-brain barrier and start causing brain damage, which we are going to talk about later on. Okay, so you take this complex. Once the albumin has done its job of transporting unconjugated bilirubin to the hepatocytes, it gets released, and then it continues and goes back to the blood system and continue transporting and doing other functions as well. Remember, there are so many functions of albumin. The transportation function is not the only. Okay, so when it gets inside, there is that enzyme that will convert unconjugated bilirubin into conjugated. That enzyme it has got a very long name. It's the UGT1A1 enzyme. This is the enzyme that will convert unconjugated bilirubin into conjugated bilirubin. And now that conjugated bilirubin will come in and form bile salts and that kind of a thing. Now it's excreted in the GIT system, right? Now the bilirubin now that we have from here is the conjugated bilirubin. The conjugated bilirubin is lipophobic, is water soluble. Because of these two properties, conjugated bilirubin cannot enter the bilipid layer. It can't enter the bilipid layer. So conjugated bilirubin cannot cause brain damage. So when you've got a kidney, that's why the phototherapy light keeps on converting unconjugated bilirubin into conjugated, because conjugated does not cross the blood-brain barrier. It gets repelled because it's lipophobic, so it cannot enter the blood barrier, so it cannot cause brain damage to neonates. So you can have huge amounts of conjugated bilirubin. The kid will not have problems in terms of that, right? Okay, now the conjugated bilirubin it's gonna bacterias, let me write it. So bacterias are gonna come in. The bacteria that are in there, remember the GIT is not sterile. There's a lot of bacteria there. One of them is E. coli. So those bacteria are gonna act on this bilirubin and convert it into urobilin, right? And that urobilin now is different. Let me go back a bit. Conjugated bilirubin, one of its properties, it cannot get reabsorbed back into the body by the enterocytes. But the minute bacteria convert it to urobilin, now it can be reabsorbed. But as long as it stays like this, it won't. So out of the 100% conjugated bilirubin that gets converted by the liver and is excreted into the GI tract, about 10% of it gets converted by those bacteria into urobilin. And urobilin is reabsorbed, it's able to be reabsorbed by the enterocytes. This is what they call the what do they call it? The enterohepatic circulation. Yeah. So urobilin is gonna reabsorbed, gets back to the liver. Some of it will be part of urine. Some of it will keep coming back and recirculating between the, that's why they call it the enterohepatic. It's between the liver and the enterocytes, liver, enterocytes, right? So some of the urobilin is gonna be excreted in the urine. It makes sense now that if you think about obstructive jaundice, once you've got obstructive jaundice, you get hyperbilirubinemia, but you cannot excrete it. So a lot of it gets converted into a lot of conjugated bilirubin gets converted into urobilin, and you get a lot of urobilin that is excreted via the urine. That's why now you get a urine that is called colored because of that urobilin. We're not talking about that though. Okay, so the urobilin, this is about 10%. The rest of the 90%, bacteria has come again and convert it into stecobilin. Stecobilin is finally excreted in the feces and gives feces that brownish color. Now it makes sense that if you've got obstruction and you're not excreting, you're not getting any bilirubin that forms part of the feces, your stools become pale. You get pale stools. That's when you've got obstructive jaundice. Very important points, guys, to remember. Remember these steps. Yeah. So this is what we have, right? Remember, we said that once unconjugated bilirubin gets conjugated in the liver, it's excreted from them, or is released from them, or it's excreted into the GIT as conjugated bilirubin, and then bacteria, they act on it, and then urobilin is formed, and then they continue to act on it and convert it into stecobilin, and then is released. So what I want you to get from here is that we said the main reason why we are converting unconjugated bilirubin to conjugated bilirubin is because we want to excrete. That's the main reason. So excretion has happened here. So excretion happened here in the form of feces, or in the feces, and here urine. So these are the two ways the body gets rid of bilirubin.